Well, I'll just spend a moment just talking about the project so that while people are joining, they miss me talking about the project rather than Adrian's chat. Welcome. I'm Guy Benton from AIforeducation.org. We're a community to ensure universal benefits from AI for education. Our mission is to make sure that children in low and middle income countries are not left behind. We are working to ensure that AI tools are appropriate to these contexts and are designed understanding the needs of learners. We want to make sure that these tools are evidence-based, technically sound, equitable, fair to everybody, and affordable, and they can reach everywhere, and able to improve learning at scale. I mean, this is a vision statement that I quite like. It's we don't know if this is achievable, but a beautiful vision is that all children will be able to use pedagogically sound, contextually relevant AI tools that understand their languages, and that will be the focus of the session today: language and voice recognition. Tell stories that children can relate to, so contextually relevant. And we've also, as some of you will know, been looking at solutions that work in low connectivity and low power situations as well. We aim to achieve this. We aim to achieve this by providing the community with knowledge products. We'll be giving lots of training and events like today. We're also investing in solutions and helping bring solutions closer, so research and development and pilots. Everything that we produce in our research will be shared, so what we learn, but also the code. Any tools that we make, we'll be sharing. We are also making sure that any interventions are evidence-based, so we're collecting all relevant evidence that we can find from around the world, but we also put together and share evidence from our own pilots. Another essential piece of our work is benchmarks, because most benchmarking at the moment is, well, the benchmarking at the moment tests whether AI can pass a maths exam, for example. But we're trying to develop benchmarks that test whether AI is successful at teaching or is actually successful at helping students to pass exams, as opposed to just being able to pass an exam itself. So it was another piece we're working on, and we'll share more soon. And then the other side is hopefully connecting people and bringing about solutions that wouldn't have happened if people hadn't been connected or ideas hadn't reached people. We have 7 pilots at the moment. We're about to announce another one soon. And one of these, I want to introduce you today to Adrian DeWitts of Bookbot, who has spent the last few years sort of developing an app to help teach oral reading fluency in Indonesia. They have demonstrable results. There's a 2-fold increase in literacy. And Adrian has just been telling me about some of his results in trying to make it work in Kiswahili. And the good news is there is a lot of success to talk about already. And Adrian is going to sort of give you a demonstration today and take some questions and respond to some questions that have already been sent through. So I'll stop sharing now and welcome everyone. Thanks for joining today.
Awesome. Can you hear me okay?
Yeah, we can hear you.
Okay, awesome. Great. I'll just share my screen and okay. Just 1 second. Awesome. Okay, can you see that screen okay?
Yeah, we can see.
Okay, awesome. So, everybody, I'm Adrian from the founder of Bookbot, and I'll just start my presentation with a origin story of Bookbot. So years ago, when my son Forrester was in elementary school, we call it primary school in Australia. So my son Forrester brought home his report, and that report showed that he'd fallen behind in his reading compared to the rest of his class. And 6 months later, his next report showed he'd fallen even further behind. We've been reading with him every night, and we got worried. And as someone who loves to read, I had to understand what was going on for him. So I read all the information that was out there, talked to everybody about how we learn to read. I learned about dyslexia. So we got Forrester assessed, and we found that he was actually dyslexic. As he read, he would read something else or mispronounce the word. So I thought, what can I do? What can I do to help? And I created a prototype of a reader that would listen to him and pronounce the word for him when he got it wrong. And it worked. And when he graduated from primary school, he actually won an award for the best reader. And at that moment, I knew that I could make a difference for other children falling behind with their reading. So the story continues. We built Bookbot, and we were asked by Australia's Department of Foreign Affairs and Trade and Indonesia's Ministry of Education to bring Bookbot to Indonesia to help with their literacy problem. And I'll talk about that a little more later as I contrast it with the Tanzania project. So first I'm going to share a demo of Bookbot so you can see it in action.
Little book of big facts. Football. Say the practice words after me. Popular.
Popular.
Street. Competitive.
Competitive.
Marvelous. Dangerous.
Dangerous.
Bravo. Actually.
Actually.
Kudos. Forever.
Forever.
Phenomenal. Okay, you can now start reading.
My friends want to play soccer.
Football. Football. Football.
Football with me, but I don't know what it is.
Okay. Yeah, so that gives you a little demo. Let me just pull up my screens. Yeah, so Bookbot is sorry, let me go back. So with Bookbot, we use principles from the science of reading. These include phonemic awareness, phonics, fluency, and vocabulary, which leads to comprehension. Our books are leveled and they double as read-along audio books. And that's where the text-to-speech works. So once you've downloaded the app, an internet connection isn't required. And we designed it that way because we knew many in rural Indonesia wouldn't be able to use it if it required an internet connection all the time. And that's something that we found that's common in LMIC. So then it's like, well, how do you store all that content? How do you store the illustrations, audio, and the speech recognition model with small storage requirements? And we found a way to make illustrations tiny while maintaining quality. We found a way, we've also built a high quality text to speech model that works inside the app. And the animation is generated in real time. And we make reading fun by adding incentives through gamification, and these include virtual tokens that allow children to earn custom bots and certificates. And it works well without impacting actual reading time. Bookbot is an oral assistive reading app, but at the same time, we collect data on reading accuracy and fluency. So it makes a great assessment app. However, teachers will mainly use it to understand how much time is spent reading. The cool thing is that when children use Bookbot over the year, their reading fluency doubles. And we found this in our data. We also did an efficacy study last year in rural Indonesia and saw some exciting results. When we ran our program in Indonesia, we also got praise, and it was heartening for our team to see how schools embraced Bookbot. We said it's like a total program, and we're trying to create that love for reading. Now, I thought, why don't we have a little fun? And I'm going to call this Guess the Generated AI, and I'm going to play some speech. One is the original recording, and another is the text-to-speech synthesis, which we actually use inside BookBot. And so you'll need to guess which one is which. I'm going to play both first. Then when I play each one again, I want you to react with a thumbs up if you think it's the original recording. See your little react buttons at the top. I think it's the same for everybody. So thumbs up if you think it's the original recording, or let's say a heart if you think it's the text-to-speech. Okay, did you get that? Okay, cool.
Yes.
Let's see if we can get this working.
Ayah memberi uang untuk membeli kaos yang aku suka.
Okay, that's the first one.
Ayah memberi uang untuk membeli kaos yang aku suka.
Okay, so I'm gonna go back. Okay, so what's this one? Hang on, I'll play it again. Oh, hang on, sorry.
Ayah memberi uang untuk membeli kaos yang aku suka.
Okay, any guesses? I'm seeing a bit of a mix. Some thumbs up, some hearts. Paula, what are you seeing? I'm not quite seeing everybody.
I think we've got a few people saying that A is the automated one.
Okay. Okay, I'm going to go to the next one.
Ayah memberi uang untuk membeli kaos yang aku suka.
Okay, what do we think is that one?
There's some debate. So I think B is human, and I think Huma agrees with me, but Anya thinks it's automated. But there's a bit of division in the views.
Okay, that's great.
So
That's good to hear.
I agree with you. I think A is automated, B is human. But I'm excited to be told that that's the opposite.
Sorry?
Will you reveal to us now, or can you...
Okay, I'll reveal. So the first one is actually the text-to-speech, the synthetic, and B is the ground truth, the actual recording. So, okay, so we're gonna do.
So I was right, I think. Good. The second was human.
Second was.
Okay, so now we're going to do one more with Kiswahili.
Siku zote ninamshukuru Mungu ninapokukumbuka katika maombi yangu.
Second.
Siku zote ninamshukuru Mungu ninapokukumbuka katika maombi yangu.
Likes human.
Okay.
Zote ninamshukuru Mungu ninapokukumbuka katika maombi yangu.
Okay. What do we think that one is?
A is human, I think.
It seems to be.
I think A is human.
So far, everyone seems to agree with A being human. We may all be wrong.
Okay.
I think it's very difficult to tell, though.
I mean, my confidence in the answer is probably about 5%. You know, I wouldn't have any real confidence in it.
Yeah. I'll play this one again.
Siku zote ninamshukuru Mungu ninapokukumbuka katika maombi yangu.
Likes human, I think.
Okay.
I think B is the AI.
So this one's the AI?
Yeah,
okay,
I
so
think
B was the AI.
Okay. Okay, so the A was the original, the recording, and B is the text-to-speech. So it kind of gives you
I have to admit to everyone that I got it right this time, but the Canadian's already done this with me, and I got it wrong on the last time, and I suspect I'll give a different answer tomorrow. So I think it's very close for me.
It's difficult to differentiate.
And you know, that's what we're trying to achieve. Okay, so I will move on. Okay, so just to give a bit of an idea of the Kiswahili like bot, and a bit of a compare and contrast between like, you know, how we, you know, the time that we like spent with Bahasa Indonesia versus like Kiswahili. Now they're both transparent languages, but when we went and did Bahasa Indonesia, we had no knowledge of how to like create a speech recognizer. I mean, we'd only had like English. You know, as our kind of like first step, but we learned a lot. So that in the first instance, it actually took 2 years to create Bookbot Indonesia, and this was like the whole thing. We had to like make books. Um, we had to create the speech recognizer, and eventually we created like this speech synthesis. The When we started the Tanzanian Kiswahili speech recognition like model, we actually built it in 1 week. We were able to put together the resources that were already there, that were there like online, all the open source kind of like stuff, and this was like things like recordings that actually already existed. We used a service called like Common Voice. Common Voice has a collection of like transcribed audio in different languages. We use that. Typically, when you create a speech recognition model, you have an error rate, like, you know, how many words that it, you know, mistranscribes or doesn't get right. I mean, English on average is around like 10%. When we first started with the Bahasa Indonesia like model, it was getting 1 in 3 words incorrect, or 30%. With our fresh kind of Kiswahili like model, our first gen Kiswahili, we were getting a 5% word error rate. So that's like it gets like 1 in 20 words wrong. So we're excited that, you know, from the get-go we're able to get something which is better than the average in English, for instance. Now with the Kiswahili text to speech, we built that in a couple of weeks. How we did that is that again we found like an open source like Bible recording. We were able to break that down into what we need is to like break it down into sentences or lines that are transcribed, and we feed it into our like system to build like the text to speech like models. So we did that one pretty quick. We, you know, kind of like leverage I guess our understanding of the language to build like both models. So also we have like a library of books, and most of those books can be used in a universal kind of like context. Those books were actually translated in a day, and really that was just slowly, like book by book, one at a time. We weren't, you know, hitting ChatGPT like all in, or actually no, I think we used Claude Opus. And we're just like doing one at a time, like really slowly. So we're able to translate that really quickly. And that becomes like a base for then human editors to come in and edit the books. And usually the translators will miss things like context. And so the human editors will fix like those things. But it does a great job. Okay. Just put this to, okay, we are finished. So we'll take a question and answer. Just going to stop sharing.
I think we had a question in the chat from Daniel. I'm not sure if you want to come on and speak, Daniel. or
Oh, yes,
I
hi.
can
Yeah, that's sure. I can come on. First of all, hi Adrian. You probably remember me from working with you guys through the venture fund in the Office of Innovation at UNICEF. Yeah, at a sort of a question you mentioned in Swahili, and I think this is a really interesting example, using word error rate for your evaluation metric to assess performance. Maybe just technically, and maybe at a high level, like why word error rate versus say like character or phoneme error rate, which is more nuanced on how people actually speak the language. Sort of that's my
Yeah,
question.
yeah. Look, I agree. I mean, internally we do, you know, internally we measure it in kind of like the phoneme, like error rate. I mean, I think, you know, the word, you know, industry like wise, industry standard wise, you know, the understanding more is at like a word error rate kind of like level. I mean, our kind of phoneme error rate's probably a bit better than the word error rate. So yeah, I mean, really, that's, you know, it's more if like, you know, people just understand, you know, understand like the word error rate rather than the phoneme kind of like error rate. But yes, agreed that of the nuance of you know, phoneme error rate. Does that answer your question?
Yeah. I mean, I guess is there anything particular about like the difference in the languages? Like I don't know anything about Kiswahili, but you know, between like for example English, which is like highly dependent, ASR will be highly dependent on who's speaking it with what accent.
Agreed,
Um,
100%.
it's like ASR is terrible for me usually when I use a lot of these systems. So I'm wondering like if there's any nuance with the language here.
Yeah, look, that's exactly right for English. And you know, like this is a continuous challenge like that we have is that you know, accents, you know, we can be great with one accent but poor with like another accent. Um, or you know, just have a higher kind of phoneme error rate with certain other accents. Or now, I mean, also like at the same time, English is an opaque like language. We don't have really clear kinds of like rules when it comes to, you know, like we have a set of characters and then, you know, like connecting that with a bunch of like sounds. Um, it's all over the place. So that's been like another kind of like challenge. Now, for languages like Bahasa Indonesia and you know, Kiswahili, they're both transparent like languages, meaning that you can pretty much you know, read it and pronounce it correctly. So I mean, I can read Bahasa Indonesia, for instance, and read it okay without really understanding it. Um, and that's what I've also like found with Kiswahili. I mean, they do have you know, kind of like consonant clusters and like certain things like in the language, but it's all very, very clear. But I mean, Bahasa Indonesia has like one exception with like the E's. You can pronounce E's a couple of different ways. But you know, like our team, you know, Wilson's here on the call. Like Wilson actually developed a model to predict how that E is pronounced in a Bahasa Indonesia word. So we we've found with you know, with transparent languages, it's just so much easier to make you know, the speech recognizers and the text to speech. Did anybody else?
we have a couple of hands up. Huma, did you want to go ahead with your question?
Yes.
Ollie? Oh, no, sorry, he was saying?
Adrian, right? This is how we pronounce
Yes,
it.
that's
Yeah.
right.
Very nice presentation and a great work. My only question to you is with the relation to Danielle's question as well. That, for example, a child can just through speech can have the only through written they can listen whatever they are writing. This is how the first step you have completed this, and now it is in English. And in how many languages it is available, because that is the only debatable topic these days, that the all AI apps and these text generated apps, are they available in indigenous languages of different countries like South Asian different countries, and their different languages? Because every 100 miles, after every 100 miles in Pakistan even, language is changed, that changed. So you have done an excellent and tremendous work. So how long we have to wait more to have these kind of apps which can translate in all kinds of languages?
Specifically translation?
Translation and generating the speech only through text, both.
We could do it in
There are
6
two
months.
things.
The whole lot, we could do it in 6 months. I mean, like when I say, no, I mean, I'm kind of like joking, but I mean, it's all quite doable. Like, I mean, it's just a matter of, I mean, when it comes to something like translation, I mean, generally we could use like a large language model to translate backwards and forwards, but we would kind of augment it with like other languages. So how we could like do that is that we could create like that dictionary, like a like a dictionary of like that other language, which has like the definition. Could have the definition in English and the definition in the actual like native language itself, and we can insert that into a prompt with the LLM, with the large language model, and then we can have it like translating. So that's all kind of like doable in the sense that there's, for a lot of languages, there's also there's all a bunch of like resources there to do that and do it quite quickly. In other cases, like certain languages won't have like all that information like documented. So therefore it would probably take like a community to bring all that information together. So this is all possible. There is a path forward with that. With things like text to speech, again, I mean, look, lots of languages are transparent. I mean, for us to build a text to speech model, we need around about like 1,000 lines of recording. And we just really need its grapheme to phoneme kind of like rules, and we just need a voice artist to go into a recording studio, and over a few days they could record a whole bunch of like different examples, and then within like a week or a couple of weeks we could then create like the text to speech model. So it's all doable. I mean, we've got the expertise to actually do it quite quickly like now. I mean, it just it costs money just in terms of like expertise and machines, GPUs, and those machines are that time can be a bit more expensive to build out like these models. But all very doable. Like quite quickly to like to do it, but just requires like that kind of investment to do each language. Does that help answer your question? Okay, so I think Anya. Sorry. Oh, sorry, Ollie. I mean, Ollie,
Ollie's got both hands up.
No, I think it's just I'm number 2 on the list, right? How's it going, Adrian? Good to see you.
Hey, good to see you as well, Ollie.
Yeah, so I guess I have a couple of questions. Like one of them is, could you give a bit more detail about the particular model that you used for both the ASR and TTS? And I think I know you kind of described the training data, but could you maybe give a bit more detail about the training data, like whether it was a mixture of like what kinds of people were taking part in that and doing the recordings? And another question, which maybe I'll ask that afterwards, but like
yeah, that'd be good. There you go. So for the speech recognition, we actually use like 2 models. So we kind of treat it like we have a high-end model and we have like a device performance kind of like model for both ASR and for speech recognition and for text to speech. So on the ASR side, we'll use Wave to Vec 2. For the ASR performance model, we'll use Caldi. For the text to speech, the high end kind of model, we're using like Style TTS. For the performance kind of TTS model, we'll use Light Speech. So we have 4 different like technologies that we're using for these different systems. What was the last question? What was the second question?
Oh yeah, so just a bit more detail on the training data, like how it was like was it how many people were involved, like how many voice actors or like and like what kind of the demographics and like.
So I mean, how like with the audio for text to speech only requires just 1 voice artist. Look, I mean, I think for transparent languages, if you've got nothing else, we need about 1,000 lines. But there is the possibilities that we can, create these kind of like base models and then do some fine tuning around it and potentially use less recording of a voice actor, and that's something that we keep experimenting with. On the speech recognition side, that's a good question. So in terms of we have typically like those collections. Now it's different for different like languages, but generally we'll have something with a bunch of different males, a bunch of like different females, and it's always like better if that you have it very, very kind of like mixed. But generally it probably skews a little bit more male. And you'll get a bunch of like kind of different accents, like slight differences in accents like within that kind of like collection. I mean, certainly like with English, it's has a huge like spread, like with all different kinds of like accents. Yeah, I mean just one thing with the Bahasa Indonesia, like when we went to like collect like the data to build the Bahasa Indonesia model, because it's a great model. It works really, really well, and that's because we got around about like 1,000 hours of children reading, and we were also able to have it quite distributed regionally. So we were getting recordings all across the island, and that's how we've been able to get something that works really, really well in all different kinds of like contexts. So again, like I mean, more data the better.
Okay, and I know I don't want to hog the questions, but like I'll just my second question, which is also kind of two questions. So like again, I guess this relates to the evaluation part, right? So for the ASR, are those those word error rates that you're reporting, are that just from like held out data from the training set, or is that from actual like on the ground are you testing the ASR performance with like the children, or is that just using the training data with like some held out data?
I mean, we'll we've cut off, like I mean, we'll slice like a set you know, that is not part of the training set, and
Yeah.
you know, we'll have like a chunk there that we use as like the test set. And I mean, we've created, you know, we've gotten like gold sets, which are, you know, fully like checked, transcribed, you know, transcribed and validated. And that's generally like what we try to do with the test sets is like we've, I mean, for English, we've actually got different accents. These are like test sets that are, that have like, you know, that are fully kind of like validated. And we've done a similar thing. So like with Bahasa Indonesia, we just carved off a set. We went through and manually validated it, and that became, you know, the test set.
Do you have any concept there of like differentiating between children and adults in the testing?
You know, originally we, what have we got now? I mean, for Bahasa Indonesia, yes, like mainly children. I mean, because our focus is children, so we have mainly like children in that test set. With English, yeah, a bit of a mix. Lots of, I guess, like lots of adults in that as well. We are now starting to find that. I mean, it used to be like the case where, you know, having lots of like child data was important. But now I think it's not as big as kind of issue as it was like before. To get like better models, we're able to you know, test on like different data or train like with different data. And you know, we're just getting generally better accuracy when we like look at it at the phoneme level.
Okay, thanks. And this is the second part of the question. Honestly, this is my last one, right? And it's just like, how do you for the TTS? Is there a like formal evaluation of that, or is it more like kind of like a human judgment, like the designer makes the decision this is better?
I like, so it's usually me. I mean, my history, I'm in a previous life, I was actually a music producer / sound engineer. I mean, there's a few things to say, like, okay, well, it's got to be, you know, the level has to be like high, but not too high. We don't want it like distorted. You know, we don't want like noise. You know, we want a good, you know, just a good condenser kind of like microphone, a very like dead recording kind of like environment. So we're just hearing the voice. And I think the thing that I've like found is that I can write all like these things down and provide like examples to like the, you know, the people that are going to like produce or like manage it. But generally, I think I've found like that's not enough. You know, I have to make like those kinds of like judgment calls to basically say, no, this is really good. This is not good because of X, Y, and Z. That actually comes up quite a bit, but I think at the end of the day that it's just really, really important to just have a great voice artist and have a trained sound engineer in the recording studio to get like the right levels, microphone, you know, make sure there's no noise, you know, do all like those different things, because it makes a massive difference in the quality of recording. I've generally found that the home studio probably hasn't been that great. And I think really, like, I mean, I've got friends with like home studios, and it is great because, like, you know, they're experienced kind of like sound engineers. But you know, generally when you go out to like go and record like voices, usually what will happen is that there will be some issues like within the recording, and it will affect the quality of the text to speech like model that's produced at the end of it. So I always just like say, just get it done in a recording studio. It makes, you know, with a professional like sound engineer, it makes a huge difference. And it's not that expensive either.
Thanks.
Sherilyn, do you want to go ahead with your question?
Yes, please. Okay, can you hear me?
Yeah.
All
Yes.
right. Okay, hi everyone. So Adrian, it's amazing the work that you've been able to achieve in Indonesia. And regarding the question, I think Huma asked about the other languages that you can handle. What is the progress so far, specifically in Tanzania? And you mentioned that you're looking at other languages. So what other languages are you looking at? And I'm speaking from a perspective whereby we've been able to successfully use AI for education in local dialects across East Africa and West Africa, specifically with farmers on agronomy and weather forecast. As well, do you offer translation services, and are you collaborating with anyone to expedite the process?
Yeah, look, we're happy to like collaborate and yes, like speed it up. Look, I think like with the translation like stuff, we're still we get the processes and we've done some experimentation, but we're a little nascent in that. In terms of like languages, where I mean we're looking at Twi, like so we've been chatting with some lovely people from Ghana, and that's something that we're like looking at as potentially one of the next like languages that we do. But we would love to do all of Africa, to be honest. In fact, we'd love to do every like language in the world. But yeah, like we're happy to I guess like provide like the advice around that. I mean, yeah, there's a bit to it. There's a bit to like the processes of getting the right quality. But yeah, I guess I'd still go back to just with creating a text to speech, getting in the recording studio and recording some just really high quality like audio. And just one other thing, I mean, we do another thing to make sure that there's like we'll build that original like script to go into the recording studio. And one thing that we try to do is to make sure that the script has kind of a phonemic balance through the whole thing. So we're getting examples of we're getting enough examples of like each sound in the language, so we get like a balance, and then we make sure like that's part of the part of like the script that goes into the recording that's used in the recording. But did you have any? I don't know if I covered it all, but was there anything else that that I could answer?
Yeah. I also wanted to know, like, how can you build translation models for low resource languages? Because, for instance, if you go to the local dialect, some of these languages are not very common. So how are you able to build translation models for these low resource languages, especially in East and West Africa?
I think, I mean, it starts with it'll start with like a dictionary. So a dictionary of like all the words in the language, and it's English description and the languages like description as well of like those words, and then that can be like fed into the the large it can be used as part of like the prompt with a large language model. But yeah, look, dictionary, basically a dictionary, and examples, and like English, English and the language, like translate like good quality like translations of like each.
Okay. So yeah. So the reason why I'm asking is because we've tried it before with the dictionary, the English dictionary, and even the Bible. But the problem comes to a place whereby this language has been completely refined, and it's not very organic when it comes to translation to that local dialect. So how would you go about that? Because you do realize that some of these African languages, there is no, we don't have books or there's no literature record for translations of these languages. So it becomes a problem to get translation through AI. You'll find that some wordings are not really as they should be. So how do you go about that? Because now there's no dictionary and there's no kamusi like Kiswahili to be able to translate it to English. Yeah.
Yeah, I mean, you have to start somewhere, and you have to build up the dictionary. Like, I mean, it's just like one of those things that um I mean, we haven't really gone into the kind of where there's not much recording of like the language. I mean, we think of it in terms of, well, we've got these examples and this like works and this like this translates pretty well. But you would need to basically, I mean, this is something where we've been thinking about, building up a dictionary tool. So, getting a whole community to contribute to that dictionary. Put in every single word, or if the words are existing, take that, but then, a person, or a community of like people will sit there and make like those descriptions and translate those different kinds of like descriptions. And really, it's just like the work just has to be, at this point in time of what we understand, the work just has to be put into like putting all that information together and collating it.
Okay, great. Thank you. Thank you.
All right.
Huma, did
anybody
you?
else?
I think Huma, was that another question that you had?
Yeah, that was me if we have time. It's Anya. Adrian, thank you so much for diving deep into this. And I think I'd love to pick up with you offline. I'm at AWS, so I want to get a little bit more technical with you. Question, you mentioned 1,000 lines is sufficient to feed into the model for it to start to learn the language. Does that mean that the 1,000 lines also accommodate for variation in accents? And sorry if you've already answered that, but I didn't catch that. And then the second question, if you want to answer now, or we can again do it offline, is I'd like to just understand more of the services that you need to get this product into Urdu, for an example, into a new language. So I've understood the steps around the LLM and then you're applying translation, but I'd be curious to understand what are some of the other services that go into this.
From the point of text to speech, or
yes, text to speech, yeah.
Okay. So really, it's 1,000 lines per accent.
Per accent, cool.
Okay. I mean, and I'll put the start, like the little star at the bottom. It could be possible to, kind of have like that base model, and then, just have have a handful of examples to kind of like fine tune the accent. Could be possible. That's something that we're experimenting a bit with. So like you have this kind of like, like a 1,000 lines of one, and then you're fine tuning that with other, like a smaller amount of like recordings to push to get an accent. I mean, what we've been trying to do is, I mean, what you typically like find is like when you go into the recording studio that it can just be that whole like process of trying to get all that information. It can be very, very tiring for like voice artists. So we are trying to find ways of getting the quality that we require, but doing it in a smaller, instead of like doing a whole week of like recordings, to be able to just do it in a session, for instance. Like that's our goal. Something that we really, really want to figure out. So you're curious about like the whole, like all the different kind of like steps that you would do to create
journey.
Yeah, okay. So I mean, typically what we need to like understand like from the start is, I guess, like like how the language works, in the sense, I mean, if it's a transparent kind of like language, with the letters that we see within, with the graphemes that we see, what sound does it make? And so like that's kind of like the first step. And there'll be nuances like within that. You'll have like digraphs, you'll have like two graphemes, and like that will make a sound, or you could have like a consonant kind of like collection, and that will make another sound. And there's all like those different things. And then there can be like variations with this vowel sound could possibly be of two different vowel sounds. Like that's what we found like with Bahasa Indonesia. So that the first part is really just, okay, here's the rule set for grapheme to phonemes. And then there can be like what we're trying to create is like a G2P model, grapheme to phoneme kind of like model. So then when we feed in like graphemes, or when we feed in like words from that like language, we're then converting it to phonemes.
Gotcha.
So that's really like the first step. And then we're going to then like create like this script, and this script of 1,000 lines will we try to have something which is very, very kind of like natural, like just natural, like the natural words of like that language spoken in a sentence. And the other part of it is that we try to have what I was talking about before was like a balance. So we want a balance of like phonemes. We want a spread of different sounds that are within the language. So English has like 44 like different like sounds. Typically we have like this issue in English that we miss out. Sometimes we can be a bit low with the zh kind of like sounds. So with other languages, we try to make sure that we have a bit of a balance of all those kind of sounds. You will have like little sounds that have like a lower kind of frequency distribution, and we try to make sure that we get more of those. So we do a bit of analysis. We have a script to analyze like our like scripts to make sure like all the sounds are well represented, and then we can adjust like that script if that balance is not there. Well then then that is like recorded in the recording studio, and each line typically at the end result should be like these 1,000 audio files and 1,000 like transcripts. It can be in it should already be there in like the script kind of like file, but we want to make sure that that script is exactly the same as like the audio that's recorded. So there can be like a validation like process, a bit of quality control, because that's really, really critical. We have to get it exact, and then we train that model from those audio recordings. So does that answer? Yeah, like those are the kinds of like the steps that we have with creating a text to speech.
Thank you. Yeah, it does. Took me on that journey with you.
Cool. So I'm sure like Wilson would say, no, that's not. Yeah. You're missing a whole bunch of different things, but I'm kind of just like, here's the, here's the steps. Yeah, were there any other questions, or I think we've got it all. Okay.
There were a few more questions on chat, but I don't know if they were all answered. If the ones who raised them could maybe speak up, would be easiest.
I think we covered those. I'm just looking at the chat. Is there a different?
Yeah, I think we mostly covered those. There was a couple of questions from the registration forms that came up. I think you might have touched on most of them already, Adrian. Maybe this one you could maybe speak a little bit more on. Someone asked, in what ways can we improve text-to-speech models for low resource languages?
The same thing just as I described. it's a matter of like just doing each of like those steps, you know, getting that.
I had a question, Adrian, sorry, just a bit more about sort of vision then, because I mean, it's fantastic what's being achieved. I mean, it's really impressive. If in a sort of ideal world, where would we be in 5-10 years with this?
I want to do every language. I mean, I've got this. I mean, we've got the process down, and we know that we could do it for every like language. I mean, and you know, there's like 7,000, you know, around like 7,000 like languages. So I'm assuming like within that we're going to have the, you know, we'll have a few hundred kind of like base languages like in there, and then the, you know, the rest will probably be dialects, and you know, we'll the dialects will probably be a bit easier to do, because we can, you know, base it up. We can always like leverage, you know, leverage other work. And that's what we always try to do, just leverage like everything that we already have. But yeah, in 5 years' time, I mean, you know, with enough resources, we could do, you know, we could do all languages around the world.
Okay, and then the next sort of question then is how where do you see that in education? I mean, what would you want ministries to be thinking about and doing to integrate this into the way they teach? Should we be sort of standardizing stuff? Should we be sort of getting guidance out to kind of get things made, standardized curriculums a bit more that would lead to making this sort of these tools more easy to integrate and in sort of teaching and learning?
I think, I mean, for like Bookbot, where I mean, Bookbot is that, you know, practice to read kind of like tool. And you know, kind of like oral reading is just, you know, it's just oral reading with feedback is just makes that huge kind of like difference. And it doesn't have to be Bookbot, it can be just another like teacher, or reading coach or parent, or whatever, to just help a child like learn, you know, just learn to read. And but I mean, you know, like that's the thing, we're filling different kinds of like gaps that are there. Sometimes like the parents can't read. You know, sometimes there isn't access to like books. You know, the internet's kind of like spotty. We're first and foremost just hitting all those different, you know, like areas, and creating something which is designed to get children into reading, you know, create like that love of reading. And it's something that we found, I mean, just with, you know, using that kind of science of reading and using like level books, that we found that, you know, when we start looking at our data, and we have like scoring for like each book, that we generally found like, you know, kids loved kind of leveled books. You know, they loved to be, they had a satisfaction when they could read a book that was at their reading level. And that's something that we're offering. You know, we've got a system in place to break down like the language and make it easier for children to learn to read and to build up their vocabulary. You know, we've designed the tools around it, and funnily enough, it kind of like helps with, you know, the work that we do around like speech recognition and text to speech and all that kind of stuff, like just understanding like the language. But yeah, look, the you know, we're that tool, and I mean, we're that tool to like help with like these things, just to help with reading and to help build that love of kind of like reading. So we work, you know, with teachers. You know, I mean, another thing is that reading is, you know, it requires like motivations to get children to read, and we try to do that within like the app. But at the start, it also like requires a teacher to help a child to, you know, like install the app, or you know, here's like the library, here's the books in like the library, just that initial kind of like little mini onboarding, into like the app. It still requires an adult. And it was something that we found with working in Indonesia when we would onboard principals, then we would like onboard like the teachers, and those teachers would then like onboard like the students. But we had to go through that process. And, you know, once we helped like teachers understand like the benefits, but also like help them with digital literacy kind of like school skills, at the end of it, we saw like more kids read books. You know, that was the thing of like how receptive we found. Like the more receptive teachers were to like BookBot, at the end of it, we just found more kids reading books in that class. So there is like that whole kind of like human aspect to the whole thing that we still need to serve.
Fantastic, and it just leads me to a couple of very quick visions for questions as well. I mean, another one is, I mean, if lots of people are using this and we get lots of feedback, what sort of potential does we get? Lots of sort of data. What sort of potential is that to analyze things at the sort of system level? You know, to say perhaps we're struggling in this country at this, or with this curriculum at this, or do you sort of imagine there's a way to kind of start to use it as if it becomes used more widely?
Yeah, certainly. I mean, we're collecting, you know, we're collecting this data at the moment for like teachers, so then they can see what the children, you know, what they're like reading, their fluency, or like those kinds of like things, and their kind of their progress through their like reading journey. But we know with like the teacher, we know what school, you know, like we know what school that they come from. So can we do a mute on that? Cool.
Oh, sorry, Adrian, I've muted you.
Can you hear me now?
Yeah.
Okay. So we know, like with the teacher, we know where they're, you know, what school that they're, you know, that they do their account. They select the school that they're at. This is specifically in Indonesia. So, you know, like from that and from like the data, we could piece it together to do that thing of like, I mean, we could have, you know, like a map, and there is that possibility to, you know, have like hotspots of, you know, good reading, poor reading, you know, like those kinds of things. So it's very, very possible from like the data that we collect.
Interesting. And another sort of vision one is just sort of what could other people start doing with this tech, who are sort of thinking in different directions to you, perhaps? I mean, if we're able to sort of share some of our code that's been developed and some of the what we've learnt, where do you imagine others might take it?
Yeah, I want to see like other tech kind of like software that would come from that. I mean, specifically with kids, you know, that are in that early grades 1, 2, and 3. They still need they need the little, I mean, with their tech, they need a little button which, you know, would play like voice, you know, which would give them instruction, which would do stuff like that. You know, they need that kind of like side of it. They need, I mean, you know, the speech recognition could be used in a whole bunch of, you know, like other kind of phonemic development kind of like software. I mean, we're really just like covering, we're covering more just like the grades 1, 2, and 3, but you know, there could still be more work done at you know, pre-primary school, like, you know, kindergarten, preschool, like that, at those kinds of like levels. There could be other stuff like just for, you know, like older like students that potentially like need remediation. So I mean, there's a whole bunch of like different possibilities that could be used in like education for this technology, but mainly that we see it for, you know, younger children who still just like need that help with you know, like learning to read and understanding words.
Fantastic. Are there any other questions out there? I know we've gone over time, but I find every time I speak with Adrian, I can keep going because there's always interesting things to elicit. But how are you feeling, Adrian? Should we wrap it up or see if anyone wants to ask any final questions?
Yeah, is there any final, or I think we're good? I think I'm getting all the can't see everybody. Okay.
Well, thank you everyone so much for attending. It's really exciting to be able to, I mean, for Adrian to give answers like I think we could do it all in 6 months is kind of mind-blowing to me, at least, and really exciting. And we really appreciate your interest as well, and you taking part in our events. There's recordings going up quite quickly of other events and conversations we're having. This one will go up too if you want to sort of share it or look back at it. We'll share the presentation and the video. We've did another technical session a month or so ago about taking LLMs offline, which that's also available. Those working with policymakers, we'd really encourage you to sort of recommend to them to watch our 3-part training program that was given by Paul, which is also available at our website. If people have future questions, also feel free to send them in. We really want to sort of collaborate. We want to, yeah, feel free to get in touch with Adrian, of course, as well. His email's in the chat. But keep in touch, ask us things, and we'll try to help, and tell us things you're doing, and we'll try to communicate and share with the community. So thank you all for taking part.